So today we will solve the problem top view of a binary tree. Top view of binary tree. So let's first understand what is top view. Suppose we have this binary tree. I'm taking some random binary tree here. So what is the top view of the binary tree? So what will we will see when we see this binary tree from the top? So first here, if we come here to the leftmost node, we will see that there is a 4. Then if we come to this line, if we see from the top, we will see 2. We will not be able to see 5 because 2 is there on top of it. Now when we come to this line, we can see 1. Now again at this line, what we can see is 3. This line we can see 7, and at this line we can see 8. So the top view of the binary tree will return this answer 421378 for this particular binary tree, right? So basically, whenever we view the binary tree from the top, whichever the nodes which are visible, those we have to print in the order from left to right, right? From left to right, from the leftmost child or the leftmost node to the rightmost node. So this is our problem statement. So we can take one more example to further understand, to just enhance our understanding. Suppose we just have the root, only root is given to us, then the output will be 1, right? Suppose we have a skewed tree here. Let's assume this is 2, this is 3, this is 4. Now if we view this line, we will see 4. Then when we view this line, we see 3. Then when we view this line from top, we see 2. And for this line, we will see 1. Right? So this is the top view of this particular skewed binary tree. So hope you have understood the problem statement. So now let's see how can we solve this problem. So this problem can be solved with pre-order traverse, not pre-order, sorry, level order traversal of the tree. Okay, level order traversal of the tree. But what is the thing? What are the operations we need to do when we are doing the level order traversal, right? So that is something which we need to think of, right? So this is our tree 1, 2, 3, 4, 5, 6, 7. So the thing is when we are iterating through a particular level, we need to store the value, node's value, which is visible from the top. Like for example, at this level, this particular node 1 is visible from the top, right? When we move to the next level, that is at this level, right? And this is let's say we can give a number to the lines which we are saying. So this is level 0, and let's assume that we give this line, we we assign this line uh, uh, a number, say 0 for this line also. So this is 0th line, and when we move to the next level, this will be our line number 1, right? This is level 1 and line number 1, right? So for line number 1 at level 1, we have to see, have we already visited some node on line number 1 or not prior to it. Let's forget the level example. Let's assume, I'll take one more example to further explain. This is our tree 1, 2, 3, 4, 5, 6, 7. This is line number 0. Okay, when we are at the root, this is line number 0. So in pre-order traversal, we will see that have we visited any node prior to the current operation, which is at line 0 or not. Okay, so since we are starting and we have not seen uh, l- anything at line number 0, So this is a they will just create one more structure to understand how the data will be stored. So line number 0, have we seen anything in the beginning? No, right? Because we are just beginning the traversal right now. So we'll store 1 here. Now we'll come to the left node and the left node. So this is line number. We'll we will basically decrease the line number value by 1 here. So this will become our line number -1. So we will see, have we visited anything at line number -1? No. So we'll store 2 here at line number -1. Now when we again do a come to the left child, this is this, and we'll again decrement line number by -1. This will become -2. So you see, have we visited any node on level -2? No. So we'll store it here. Now we'll visit the right child of this, the right child of 2. So for this, the line number will be, so whenever we move right, move left, we decrement the line number by 1, and whenever we move right, we increase the line number by 1. So here, in this case, 2 is at line -1. So when we move right to its right child, 5, we will increment the line number by 1, so our line number will become -1 plus 1 is equal to 0. So this is basically this node 5 is at line 0. So have we visited any node before 5 which is at line 0? We'll check here. Yes, at line 0 we have already visited 1, so we'll not visit 5, right? We'll not store 5 here because we have already, from the top if we see, we can already see 1, right, which is just above the node 5. So we will not store it in our data structure. Now we'll move to the right child of this root node. So this is that basically line number 1. We will increment the line number by 1, right? So at line 1, have we seen anything, any node? No, right? We have seen at line 0, -1, -2, but not at line 1. So we'll just add that. At line 1, we have seen 3. Now we will come to the left child of 3, which is at line 0, because when we come to left, we decrement the line number by 1, right? So this is at line 0. So at line 0, we have already seen 1 from the top, so we'll not store anything. Now we'll come to the right child, which is at line number 1 plus 1, 2. So at line 2, we have not seen anything yet, so we will just store node number 7 at line 2. So this will be our output. So this is the output. This is what we will see from the top when we visit this. When we traverse through this tree using pre-order travel, sorry, level order traversal. Correct. So let's see how will we implement this. So for implementing, we'll follow a normal level order traversal algorithm using a queue. But how do we store this value? How do we store uh, store the nodes which are visited, or which are basically on the top on each line? So for that we will need an unordered map of type int comma int. So what we will do here is, when we are visiting a particular node, we will also store the line number at which that node is, right? So in our queue for pre-order traversal, we will store the node pointer as well as the int which will store the line number, right? This will be the structure of the queue. Now in the unordered map, we will see that at a particular number, line number, if nothing is there, okay, if it is empty, then we will insert the current node at this particular node data or node value at this particular line number. If something is already there, then we will not insert anything here. So this is how this will work. So let's try to write this code on this platform. So first let's see what are the constants given in the problem statement. So this is the example, this same as the example which I shown just shown you. For this, the top view is 10. Then for this line, it is 4. Then for this line, it is 2. Then 1, 3, and 6. So this is the top view of this tree. The constraints is 1 is less than equal to t is less than equal to 100. So there are test cases can be 100, and the number of nodes can be 1000, and the data in the node can be in the range of 10 raised to 6. So there is a possibility that there can be no nodes in the tree, right? So that's why number of nodes is 0. So, and since it is 1000, we can store it in the int in an integer variable, and the data value is also in the range of 10 raised to 6. It means that we can store this value in an integer variable. That is possible. So these are the constants. So first we will see the corner case, like when number of nodes equal to 0. So in that case, the root will be null. So we'll handle that case. But before that, let me, and we have to output this in a vector of integer. So we will just define one, declare one, say let's name it answer. So this is what we will return. This is a vector of int, and if root is null, we will not insert anything in our vector out answer vector, and we'll return it as it is, a blank vector, empty vector. Now what do we need to do here is, so this is this sample, we'll see one sample output and input. So this is one the input, and for this the top view is 842137, where 9, 5, and 6 will be hidden, right? And we will take another sample to understand. So for this, our top view is 42136. Awesome. So now let's start the a level order traversal. So for that we will tree node and pointer and int. So this will be a pair basically. So let me declare it as a pair. It is a pair of node pointer and integer. So integer will store the line number at which a particular node is. Now we will push the root and 0, since root it as line number 0, right? So we will push root comma 0 while queue is not empty. We'll run the level order traversal. We'll first take the front element of the queue, tree node int pointer temp equal to queue dot front dot first, and we will take say line number is equal to queue dot front dot second. Now we will pop the element from the queue, and we will see that, and we need an unordered map also for storing the top nodes at each line. So we will just name it top nodes. So now we have to see if something is there at this particular line number or not. So if top nodes dot find line number is equal to top nodes dot end. It means that this line number is not in the top nodes map, unordered map. Then in that case, we will insert the current node data, which is basically val here in our unordered map. Now we will continue with our as usual level order traversal. So if temp left is not null, then we will push left subtree of temp or left node of left child of temp and line number -1. Similarly for the right child, if temp, sorry, right, then q dot push temp right and line number +1. This is our level order traversal. Now we have to go through, and instead of unordered map, I think we need to store an ordered map, which is basically a map in C++, because we have to print the output from left to right direction, which is basically the from the smallest line number to the largest line number. So we'll use a map because it has the data in a sorted order. It will store the data in a sorted order. Now we will iterate through the map and we will insert the node value at each line number in our answer vector and we will return the answer. Let's see if this is correct or not. There is a problem. Okay, it should be top nodes, not map. And yeah, all the test cases are running fine. Let me submit this. Even the large cases, test cases are submitted, are correct. So now this is the solution is correct and it has passed through all the test cases. Now let's see what is the time complexity and space complexity for this. So let's first analyze the space complexity. So we are using a queue which will basically store all the nodes of a tree in the worst case. Actually, it's not possible, but let's assume in the worst case that we have order of n nodes in the queue, and in the map also in the worst case we can have big O of n or order of n number of nodes, where n is the number of nodes in the binary tree. Actually, it's not possible. It will be always less than n, but that is the worst case. That is in the worst case. Now, let's find out the time complexity. So the time complexity for level order traversal is big O of n because we are traversing through each node exactly once. So the time complexity is big O of n for the this while loop, and if we come to down to this for loop, for this also the time complexity in worst case is big O of n. So our total overall time complexity is big O of n, and space complexity is also big O of n. So hope you have understood the solution. If you have any questions, you can comment down below. Thank you so much for watching this video.